Hello everyone, my name is Alima Ballo and today we'll talk about the motion of a ball at constant velocity. We'll discuss the concept behind this experiment, the data collection, the coding part, the results and analysis, and the conclusion. This experiment was based on Newton's second law, who stated that the net force acting on an object is proportional to the mass of that object's time the acceleration. In other words, if a body is moving at a constant velocity, so not accelerating, the net force acting on it is zero. From this formula, we deducted the change in velocity and the change in position. We then compared the computational model and the data extracted from the video. We analyzed it and noticed some difference and similarities that we will discuss later in the presentation. Data collection. Here is the motion of the object on a flat surface. We uploaded the video into Tracker and were able to extract the position of the ball versus time. We also extracted the initial condition of the ball, calculated the average velocity, which was the difference in position over the difference in time. The axes chosen were positive x on the right direction and positive y upward. The diameter of the ball was 4 centimeters. Coding. As saw earlier, the ball initial position and velocity were uploaded into the code. We set our delta t to be equal to 0.01 seconds, while was allowing the sequence to be repeated for every t under this time. We set the net force equal to 0 because the object was not accelerating, and incorporated both general formula for the ball velocity and the ball position. Here's the simulation of the code into GlowScript and the table of the position of the ball versus time. Results and analysis. We generated a graph with both motion, and we can notice how close their slopes are. However, the observed motion slowed down in time. This could be explained by the air resistance or the friction against the table, which didn't leave the velocity to be constant or the direction. If we were to flip the axis in Tracker xy, the slopes will become negative, but the relationship between the position and time will remain the same as shown right here. Conclusion. This experiment showed us that the observed motion was well predicted by the computational model, despite some variations. It shows us that Newton's second law of motion was valid. However, what we couldn't deduct from this experiment were the number of forces acting of the system, pushes or pulls. I made this little illustration to show that for any x, y, or z axis, as long as the system is moving at a constant velocity, there should always be same magnitude but opposite forces along the axis to allow the sum to be 0. This is the end of the presentation. Thank you for watching.